All right, so can you guys see my screen now? Hello? Can you see my screen or no?
Yes, sir.
All right. So I hope you guys have done an advanced reading regarding with our module 3. Okay. Well, this is only slide 32. Yeah, 32 slides only. So this will only take short, maybe 1 hour and 30 minutes, more or less. All right. So without a further delay, let's start. So the topic for module 3 is sequences and strings. Okay. So of course, first we have to know what is sequence. So from the beginning of it, it's a list of objects arranged in a definite order. So take note, it's a definite order, meaning arrangement in sequence is very important. So unlike sets, it is not that important, but in sequence, it is very, very important. So this in concept, it could be either finite or infinite sequence of objects. And then that elements under sequence could be distinct or repeated. Okay. So in set, it is distinct, but it is not repeated. Okay. So that's their only difference. So in sequence, it's arranged and it's repeated. Right? So we have here examples wherein we have 1, 0, 0, 1, 0, 1, 0, 0. As you can see, this one is finite and repeated. For the next example, we have 3, 8, 13, 18, 23. So as you can see, this one is infinite, okay, just by putting 3 more dots, okay, indicating that there's more elements from it, okay. And at the same time, this one is distinct because this one is exclusively, like if you're going to take a look at this one, 3 followed by 8 followed by 13, 18, and then 23. As you can see, there is a pattern, right? What is that pattern? Hello, guys. Can you guys
5,
still
sir.
follow? So this one is, or the second term can be identified just by adding 5 on the past term. So 3 plus 5 is 8. So for you to be able to identify the next one, so just add 5. So 8 plus 5 is 13. Then the same. Next one. So 13 plus 5 is 18. And then 18 plus 5 is 23. So as you can see, this one is distinct. Or in other words, we call this one recursive. All right. So when we say recursive, okay, I'll make it short. When we say recursive, the past terms are important for you to be able to get the next term. Okay. So what is the third term? You have to know what are the past two terms. What is the fourth term? You have to know what are the past three terms. Okay. So from that, you will see the pattern and then you will know what to do and how to get the next term. Okay. So we also have this one, 1, 4, 9, 16, 25. Okay. This one is the least of squares of all positive integers. Okay, so you could say that this one is also distinct and infinite, but this one is more on explicit. Okay, so the difference between explicit and recursive is for recursive, you have to know the past terms, but for explicit, you only need to know the formula. Okay, there is actually a given formula. We're in here, it says here, list of squares of all z plus. So z plus are positive integers. Where in positive integers, you will start with 1. Okay, onwards, 1, 2, 3, 4, 5, up to infinite. And then just square it. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on and so forth. So from there, you don't need to know the, what are the elements on the first, second, third. All you need to know is the formula, okay, which is this one. That is why it's called explicit. All right, so did you guys get this one so far? Hello?
Yes, sir.
Right, so I hope this one is clear. So it's finite and repeated, it's recursive, and then it's explicit. All right, so we have here the kinds of formula. So we will start with the recursive. So as I said a while ago, recursive is a formula that refers to previous terms to define the next term. So you have to know the previous terms for you to be able to know the next term. Okay. So it must have a starting number. So if there is no starting number, then that must be an explicit formula, or that must be an explicit kind of sequence. Okay, so we have this sequence 3, 8, 13, 1823. So the same, this one is example from the number 2. So a sub 1 here is indicating that this is the first term. Okay, a sub 1 is 3. Okay, and then we have this formula wherein a sub n is those terms. So first, second, third, fourth, fifth. And then this a sub n minus 1 plus 5. So as you can see, for you to be able to get the something, okay, for something position, first term, second term, third term, fourth term, you have to know what is the last term or the value of the last term. Okay, so from there, you could substitute the value of that first term in here, and then you will be able to get this second term. Okay, but before that, okay, you have to know that the range of this one should be start, okay, 2 and above, or equal to 2 and above, right? Because this is already the a sub 1, right? And then this is the a sub 2, which is now this one. Okay, so this is our starting point. So actually, you can remove this one as long as you know the first term and then you know the formula, then you're good to go. You will already know what are the following terms. So for example, this one, you already know the first term, then you will be able to identify also the second term just by knowing this formula. So a sub n minus 1, so just plug in the value of a sub n, okay, or a sub 1 rather, which is this one, plus 5. So a sub 1 is 3, plus 5 is equal to 8. So the same with this one, so you have to know what is the value of a sub 2 for you to be able to get the a sub 3. So a sub 2 is 8, plus 5 again, which is now 13. So again, for you to be able to know the a sub 4, you have to know the value of a sub 3. So a sub 3 is 13. So 13 plus 5 is equal to 18. Sorry, why is this 23? 18. So that's the correction. So I'll just update this one later on. So 13 plus 5 is 18, and so on and so forth. So as you can see, this is our a sub 1. Oops, this one. A sub 1, a sub 2, and then a sub 3, and then a sub 4. So I just didn't include the a sub 5, which is 23, right? So that's the concept of recursive. So you have to know the last terms for you to be able to get the next term. So were you guys able to get this one?
Yes, sir.
All right. How about the others?
Yes, sir.
Yes, sir.
Okay. So I hope you guys really will able to understand this one, because this one is super easy. All right. Next one is explicit. So this one is a formula that provides a value of a term using only its position number. Okay. So you don't need to know the past terms, what are the patterns, and so on and so forth. So in here, the formula is already given. Okay, so as long as you know the formula, which is, for example, this one, okay, n squared, okay, and then you have, you know the range, the starting up to the end. So it says here that your n should be less than or equal to 1. Less than? Yeah, less than. Is it correct? Less than 1 or equal? See, other way around. So n should be greater or equal to 1. Okay. So maybe it would be better if it should be something like that, and then 1. Anyway, this one is something like that. So n is greater or equal to 1. All right. So from here, as you can see, this one is has a pattern, the same with recursive. But in here, you don't need to know the first term, second term, third term, fourth term. So in here, as long as you know the formula, then you're good to go. So for example, you want to know the 10th term. So just substitute here the value of 10. So 10 times 10 is 100. That's already your 10th term. Okay. And here, we've only shown up to 5th term. Okay. So 5 times 5 is 25. 4 times 4 is 16. 3 times 3 is 9. 2 times 2 is 4. And then 1 times 1 is 1. All right. So you could say that explicit formula is a lot more easier than recursive, because in here you have to know the pattern, and at the same time you have to know the formula, okay, the correct formula. So were you guys able to learn the difference between explicit and recursive?
Yes, sir.
Yes, sir.
All right. Okay, so let's have more examples. So write the sequences of the following recursive formula. Okay, so take note, in recursive, you have to indicate everything. Okay, so the steps on how did you come up with C sub 3, C sub 4, C sub 5, and then C sub 6. So you can say that this one is quite a lot longer when it comes to solving things. So let's just say that you will put 5 following terms. 1, 2, 3, 4. Yeah, 5. Okay. So your starting point is 5, and then here's a formula, and then here's the range up. So there is a range already. So as you can see, this one is ranging from 2 up to 6. So 2, 3, 4, 5, 6. Okay, so that's why we have a total of 5 terms. And then for you to be able to get the C sub 2, you have to know the C sub 1. Okay, so this substitute here. So to our formula, so what is our 2C sub 1? So C sub 1 is 5, so 2 times 5 is 10. And then for C sub 3, you have to know the value of C sub 2. So C sub 2 is 10, so 10 times 2 is 20. And then just keep on doing that. So just substitute the last value and then put it on the formula, and then just multiply by 2. And then you will be able to get the sequence already. So from here, we have 10, 20, 40, 80, 160. So it keep on doubling its past term. Okay. So just multiply this one by 2, by 2, by 2, by 2, by 2. All right. So were you guys able to get this one?
Yes, sir. Nakuha po.
Okay. So there are two questions when it comes to recursive. So it is either it is asking you the first 5 terms, okay, which is like this one, or it is the other way around, wherein this one is already given and then you have to identify what is the formula. All right. So those are the only questions when it comes to recursive. Okay. All right. Next, we have here another recursive formula, okay, wherein our first term is 3, and then here's the formula. So just keep on adding 4. So 3 plus 4 is 7, plus 4 again is 11, plus 4 is 15, and then plus 4 is 19. And so on and so forth. So just keep on doing that one, and then you will get all of the possible terms for this sequence. So 7, 11, 15, 19, 23. Okay. So are we clear so far regarding with recursive formula?
Yes, sir. Clear naman po.
Okay. Is there anyone who's confused? All right, so I guess not. So in recursive, the one thing that, or the first two things that you need to look is the starting point, and then what is the formula, and then the last one is the range, okay, or where were you going to start? So in here, you're going to start at 2. All right, so once you're done in understanding those examples, so of course you're going to have a seat break, okay? So this one is quite long. So for the first one here is the write the sequence of the following explicit formula. Okay, so take note this one is explicit formula. So do it handwritten, and then of course, please write logically and then take a picture of it clearly. Okay. So we have here number 1 and then number 2. And then for number 3, we have this one. So blue taxi, blah, 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 blah. And then this is the mileage, and then this is the cost. So we have 2 questions here. So write the recursive formula for this one, and then write the explicit formula for this one also. All right. So I'll give you guys 10-15 seconds to take a look at this one. Okay, so is it clear? Is the instruction clear?
Yes, sir.
All right. Of course, after this, there is a continuation, which is number 4 and number 5. So if the sequence formula is given as t sub n is equal to n squared times 1, wherein n is less than, greater or equal to 1, so write the first 5 terms of this sequence, and then find the 55th term for this sequence, or for this, or using this formula. Okay. And then for number 5, the sequence is defined as x sub n is equal to 1, 2 raised to n. And then your n is ranging from -1 to 4. So write the elements of the sequence. So in here, just write 5, the first 5 terms only. You don't need to write everything. So -1 up to 4 only. Okay. So are we clear so far regarding with number 4 and number 5? -1, 0, 1, 2, 3, 4. Sorry. This one is 6th term. Okay. -1 to 4. 1, 0, 1, 2, 3, 4. Yeah. 6 terms, including the 0. So is the number 4 and number 5 clear so far?
Yes, sir.
How about the others? Nag-breakfast pa kayo?
Yes, sir.
Makain na ba habang nakikinig? Alright, so I hope you guys have already ate your breakfast, so you have mood to listen with our, or in our discussion right now. Alright, so that's it for the seat break number 1. So let's now proceed to the next. So next one is types of sequence. So we have 2 types of sequence. We have the increasing sequence and then the decreasing sequence. So as you can see, this one's very obvious and self-explanatory. So increasing sequence is, of course, any pattern as long as it's increasing. So as you can see, this is a sequence wherein it's increasing. So 2, 4, 6, 8, 10, 12, 14, and so on and so forth. Okay. So in a sequence, there is always a pattern. You just remember that. So it's not just increasing randomly. So it's not like 2, 4, 10, 15, and then 18, and then 35. So it's not like that. So in a sequence, there is a pattern wherein in here, it's increasing by 2. Okay. So if we have increasing, we also have decreasing. Okay. Wherein it's decreasing by, or it's keep on dividing by 2. Wherein it's decreasing, of course. So starting from 2 became 1, then divided by 2, divided by 2, divided by 2, and so on and so forth. So 1/4, 1/8, 1/16, 1/32, and so on and so forth. Okay. So those are the types of sequence. So I guess this one is needless to explain anymore. Anyway, so the next one here is your seat break number 2. Okay, so this one is actually super easy. Okay. Like Literally super easy. So write the first four terms begin with n is equal to 1 of the sequence whose general formula is given as those. So we have already a given general formula. So all you need to do is write the first four terms of those given formulas, right? So we have this for the letter A. And then we have another one for letter B. So write the formula for the n term of the sequence identified as recursive, explicit, or both. So in here, there's two things that you need to do. So write the formula for the n term, okay? And then identify that formula if it's recursive, explicit, or both, okay? So we have 7 numbers for this one. So you could say that this one is the opposite of letter A, okay? And then for the last one, this one should be letter C. For the sequence B defined by, so V sub n is equal to n factorial plus 2. So your n is greater or equal to 1. So find the value of B sub 3, find the value of B sub 4, and then find the value or the summation of ranging from 1 to 4. So later on, we'll discuss what is the summation so you can answer this one summation. So as of now, we only know how to answer letter A, letter B, and then letter C, letter A, and B. But for C and D, so we will discuss this one or more example of this one later on for you to be able to answer this part of your seed work number 2. So the same concept. So write it handwritten or late handwritten. If you can do it on the Microsoft Word, then better. But if you're going to do it handwritten, but uh, yeah, if you're going to do it handwritten, please write legibly. All right. So again, I'll give you guys 10 to 20 seconds to take a look on this seat work. So if you have a question or clarification, so just ask me. All right. So is it clear or no?
Okay naman, sir.
All right. So at first, at first glance, this one is quite a lot of work, but actually in reality, this one is super easy. Okay. So that is why there's a lot of numbers. How about the others? Is it clear or no? So let me know so we can explain that part wherein you're getting confused. So how many are we now? So we are now 17, right? So not bad. So before we were 18, 19. Right now we are 17. All right. So any questions so far before we proceed to the next topic?
None, sir.
Answer.
None, sir.
All right then. So the next one is sum and product notation. So maybe some of you or most of you already familiar with this one. So we have this defined as if this a sub 1 is actually the given formula or given notation. So it could be a summation or a notation. Okay, so if it's summation, then you have to get the sum of all of those given numbers. And then if it's notation, then you have to get the product of all of those given product. Okay, so this one, as you can see, I is equal to m, and then we have here letter n. So this is the range of the given formula, okay, or given annotation. So I here is the index, okay, wherein it is always equal with the lower limit, okay. So for example, this one is ranging from 1 to 3, 1 to 20. So your m here is equal to 20, and then n is the upper limit, wherein it is 20. Meaning, you have to get the sum of 1 to 20, or you have to get the product of 1 to 20. So if it's sum, then 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to plus 20. And then if it's product, then it's multiplication. So 1 times 2 times 3 times 4 times 5 up to times 20. Okay. So those are the difference of, okay, just the operator. So instead of plus, it's multiplication. Instead of multiplication, it's addition. Okay. So were you guys able to follow this one so far?
Yes,
Yes,
sir.
sir.
Sa example ko siguro magigets lang.
Yes. What is that? Seems that someone speak quite a sentence, but I didn't understand. I think it's Mr. Agustin. Do you have a concern? You want to say something? Mr. Agustin? All right. So he's not responding. So maybe he just left. Anyway, so this is the uh, bare concept of the sum or the summation and then the geometric, okay, or the product. All right. So let's have an example for you to be able to understand this one. So let A be the sequence defined by an explicit formula 2 times n or 2 sub n. That is A sub I is equal to 2n, okay? Wherein your n is ranging from 1 to 3, okay? So as you can see right here, we have the summation and then the notation. So for the summation, okay, so we have this formula, A sub I, wherein this A sub I is 2 times n. So if you're going to elaborate this one further, this one is actually A sub 1, A sub 2, and then A sub 3. Okay, so where did we get this one? It is the range from the lower limit up to the upper limit. Okay, and then as you can see, this one is incrementing by 1. So it's by it's A1 plus A2 plus A3. And then what is this A1? Okay, so A1 is 2 times n. Okay, so this A is the formula wherein it's 2. This one is the same with this one. So 2 times 1 plus 2 times 2, which is A sub 2 now. And then the next one is plus 2 times 3, which is the A sub 3. Okay, so just add all of those, then you will get 12. So this is the summation total of the, or let's say this given formula, okay, which is 12. And then for the product, okay, or geometric, okay, so instead of addition, just make it into multiplication. So 2 times 1 times 2 times 2 times 2 times 3 is equal to 48. Okay, so when it comes to summation and then geometric, okay, So the first thing that you need to know is the formula or the given formula. So what is this a sub I? Or what is this I? Okay, sometimes this is only I. And the next one here is what is the range? Okay, what is the starting point? And then what is the limit? Okay, so lower limit and then the upper limit. Okay, so understood or no?
Understood, sir.
All right, so this one is quite easy anyway. All right, so let's focus on summation for now. So this symbol for summation is sigma, okay, or this letter E, look like E. So it takes a sequence of numbers and turns it into a sum. Okay, so symbolically, this is the like the default. Okay, oops, default formula for the summation. So we have the limit, so 0 up to the end, and then we have this a sub I. Okay. So a sub I is starting from 0 since I is 0 up to a sub n since it's quite infinite. Okay, we don't know when will it end. So a sub 0 plus a sub 1 plus a sub 2 and so on and so forth. So this is read as the sum from I to 0. Okay, from I to 0, from I is equal to 0 to I equal to n. So from I to n. Okay, so that's it for the summation. So we have here the continuation. So consider the identity sequence a sub I is equal to I. So as I told you a while ago, this a sub I is just sometimes or mostly just I. Okay, or listing elements of 0, 1, 2, 3, 4, and 5. Okay, so the sum of the first n numbers is given by this formula. Okay, so again, this one is just increasing by 1. So I is equal to 1. So this is your starting point. So you start with 1 and then up to the maximum, okay, or the upper limit. So in here, the first term 0 is dropped. So why is that? Because that depends on the index or the lower limit. Okay, so in here we've started with 0, so you have to include 0. But in here we've started with 1, so we have to start with 1. Okay, so this is your indicator. Where will you start? All right. So did you guys get this one so far? So again, take note that sometimes this a sub I is equal to just I only. Okay. So they are just the same. Any concerns so far?
Yan naman po, sir.
Okay, so just let me know if there is a part that's quite confusing or quite questionable. Okay, so that we can go back on that part and then explain it again. All right, so since we don't have enough time anymore, so we will just continue the rest 15 to 32 on the part 2. Okay, so just wait for my part 2. Okay, since we will start right away once you guys are already in here. So right now there's a total of 17 participants. So once we've completed this 17, then we will start right away. All right, so I will stop this one now and then just wait for the part 2. Okay, so goodbye for now.
Sige po, sir.